Hi, hello there. So what I'm going to do in these set of videos is I'm going to deal with some of the more, well, they're easier to talk about when you're talking about them as opposed to try it and do them on a computer. But we'll have a go. So today we're gonna delve into the world of algorithms. And for those who don't know, what is an algorithm? Algorithm is a step-by-step process for doing something. If you want to put it into plainest English, so a recipe is an algorithm. Learning a dance move is an algorithm. Your brain uses algorithms all the time. So we're going to look at algorithms in all their shapes and form. But today we're going to concentrate on one particular aspect, and it's probably the key kind of fundamentals, which is the idea of the computational thinking. So computational thinking, well, I suppose computation thinking is all about the steps you do in order to find the best solution for anything. Okay, so it's the nub, it's the kind of it's the seed from which all algorithms grow. Okay, and there's really three key techniques that we use. One is the thing called decomposition. Okay, so decomposition, for want of a better word, is the use of, I suppose the best way of describing decomposition is the breaking down of a big problem into smaller problems and solving each one of those smaller problems individually. So at least that way you've got a kind of an idea of how to kind of put them back together. So one way of thinking of it would be, let's say you have all the letters in the alphabet and you want to find a word. Well, decomposition might be to break down all those letters into different patterns of letters, like what letters go together. Like, most words have to have a vowel in it, and you put all the vowels separate to everything else, and you just build up your your problems that way, and it works. It does work. So that's decomposition. And then you've got to look at the idea of what's called abstraction. Now, what does abstract mean? It means something out of the normal. Okay, so abstraction is obviously picking the small bits. So really, it's just pick the important bits of info and ignore the specific details. Okay. So just get these down here in case anyone does want to rewind. So abstraction, picking the important bits of the information that is relevant to any problem and ignoring all this bits. So for example, the one I always kind of joke about in maths when I'm teaching maths is, Anne and Barry had, 4 eggs and 3 chickens, how many different ways can they, make an omelet or something like that, something silly like that. Well, but in abstraction, you'd pick the important bits. So from that, you'd pick 3 and you'd pick 4. And you ignore the fact that it's 3 eggs and 4 chickens because they're not important to the sum. They're just the superfluous, or they're just the fluff that's coated on it to make it to cause interference with your particular problem. Okay, so picking out the information that's relevant, that's actually needed, and ignoring the specific details. Another way of doing this abstraction is using code. So rather than, and we use this the whole time, when we're using maths, we talk in English, but when we're writing maths, we write it in an abstract language, the mathematical language, because it gets rid of all the specific details and just zones in on the important bits of information. Okay, and then the third thing is, the third kind of leg of this stool is algorithmic thinking. Okay, and basically what we're looking at is the logical way of step-by-step solving the problem And then the beauty of an algorithm is if you know have a step-by-step way of solving a problem, you can then apply that step-by-step method to another similar problem. And that allows you then to do an awful lot of extra stuff. So where can they be used in real life? Okay. Let's think. We will use a very, very simple example. Now, I know it's not an example that we're going to be able to use this time. Okay. But for example, you decide to go to the cinema with friends. So that's our scenario. Okay, so we're going to see how every one of these will, push some detail onto it. So let's think about this for a second. Okay, decomposition. Okay, let's break down the big problem of going to the cinema into smaller problems. What type of films are on? Straight away. Okay, so you've broken down the big problems into smaller problems. Okay, the big problem is you're going to decide to go to cinema with friends. So you all have to agree on something to go to see. So I suppose decomposing that big problem in what they're on. Well, what else do we need to know? We need to know what times they're on, because some friends mightn't be able to come at other times. And is there any other thing that'll help us determine our choice? Well, maybe, what the movie is like, genre, reviews that have already been given to it. Okay, so abstraction. Let's take all the important information from what we've decomposed. Okay, the start and end time. That's all we need when we're talking about what times the cinemas are on. We just want the start and end times. Okay? When we're talking about what type of films, we want the genre and maybe the age rating, because that will determine whether some friends can go and some friends cannot go. Okay? If there's reviews, well, the only piece of information you need from the reviews is the star rating. You know what I mean? What's it given out of 5 or 2 thumbs up or whatever. So you can see you can decompose and abstract lots of things. But then if you go into the cinema, how does algorithmic thinking help? Okay, so what would you might decide? Well, you might decide as a group the following. Okay, and I'm going to give you an example. Okay, step 1, list all movies. Okay, there's step 1. Okay, step 2, list all times. Step 3, list all ratings. Okay, step 4, ignore movies before 5 p.m. and with ratings less than 3 stars. Okay, and you see the process. Okay, so you're using what you've actually done before in a step-by-step logical process to determine what you're going to go and see. Okay, if the family wants to see the movie the following week, they don't have to start arguing again. They'll just bring out this again. They'll list all movies, list all times, list all ratings, ignore movies before 5 p.m. and with ratings of less than 3, and then any other criteria that they want to add in. Okay, so that's the idea behind computational thinking in terms of decomposition, abstraction, algorithmic thinking. There are other things we could add in, for example, pattern recognition. Okay, if there are particular patterns, for example, if you know everyone in the family absolutely hates romantic comedies, well, you could add that into your algorithmic thinking. So that would eliminate stuff at the very start. Okay, so where does this come into in computer science? Because that's an example from the real world. Okay, so let's think about it. I want you to sort the premiership teams by alphabetical order. or anything. But let's just check the partnership teams because it's on my mind recently. Okay, so imagine that's the task. That's the task I've set you to do. Okay, so decomposition. What can we do? So decomposition. Let's break the problem into smaller problems. Right, smaller problems. Okay. The first problem I can see, alphabetical order. Is it first name, second name? You know, Manchester United. Okay, so that's the first problem. First word, you know, which word gets sorted in name? Because obviously, if it's the let's say you take Manchester United. Manchester United. Well, if we're deciding it's going to be the first word, well, then it's the Manchester that's going to be this one that's going to be sorted, because then when I come down to Arsenal or Brighton, which is actually Brighton and Hove Albion, there you go, there's a 4. So if we're just going to be sorting by that, but then we need to, when we're decomposing this into smaller problems, that's the problem. We need to identify the first letter in the first word. Now, is it upper or lowercase? There's another problem we need to solve. So we need to be telling the program, a computer scientist and a programmer, we need to tell it to recognize upper and lowercase. Sorry, we need to tell it to recognize whether it's uppercase or lowercase to sort by. You know, they'll all be uppercase, we know that, but you have to, you know, account for the possibility that they're not. Okay, so that's decomposition. Some would be straightforward and some of them mightn't. For example, you know, that's grand when you're dealing with proper names. What about things that have numbers, that have letters, that, you know, we have to have a way of doing that. Okay. For example, what happens if a load of them have very similar names? Like we have Manchester United and we've also got Manchester City. So then you'd have to come looking. Okay. So abstraction, then, how can we abstract? Okay. Do I really care whether it's Manchester United, Manchester City, Arsenal? No. What cares to me is the order in which the letters are appearing in order to sort. So obviously I look, first of all, at A's and then B's, then C's. But if I have 2 A's, then I look 1 in. I look at AR, versus, you know, so that's abstraction would help me to focus. In other words, get rid of all the superfluous one, and we're just really focusing. We don't care that their names or don't care their position. We just care that we're going to sort them in a particular way. Okay, then algorithmic thinking. How's that going to help me? Well, algorithmic thinking is just going to compare them in order. We know it'll just put together all my bits. Okay, my rules. First thing I'm going to do is I'm going to sort them by the first number. So for step 1, sort by first letter, first word. Okay, that sorts a load of them out straight away. But then I come across the 2 Manchesters. Okay, so what do we need to do? If first letters the same, check second letter. And then so on and so forth. And eventually it'll sort them in the order you want. But it could take a bit of time. Okay, and that's what algorithmic thinking allows you to do. Once you've decomposed the problems and broken them into smaller problems, and once you've abstracted all the relevant pieces of information you need in order to solve those problems, then algorithmic thinking allows you to put all those bits together in the right order in order for you to get it right. And I suppose that's the important thing, for you to actually get it right. Okay, so that's just a quick introduction to it, computational thinking. We do use it quite a lot. Okay, we do use it an awful lot. But I suppose the main thing to kind of look at it is that when you're dealing with computational thinking, and when you're dealing with any type of, you know, computer science-based algorithmic, you know, formation, okay, when you're dealing with it, you have to be able to kind of verbalize it, or in this case, you have to be able to kind of look at it in terms of what its it's doing. Okay, so if we were just to kind of put it all together into your head, kind of one final, bit and bob. Okay, you've got your decomposition, you've got your abstraction, you've got your algorithmic thinking itself, and you also have your pattern recognition. And I would say pattern recognition, while you might think it's more of a mathsy thing, what's this pattern 2, 4, 6, 8, 10. Pattern recognition, when you're dealing with computer science, when you're dealing with a problem you're trying to solve, sometimes you'll see the same pattern in the data. Sometimes you'll see that one part of your problem is actually quite similar to another, and the two problems tend to occur at the same time. And if you could spot that, then sometimes solving one problem solves the other problem. And that's your pattern recognition. And that can be a pretty cool little thing to kind of work on. So that's the start for today. You won't be getting any homework on this one. I'll be setting an assignment for you later on in the week with regards to the coding. But what we're going to do is that hopefully this will all build up into a nice little resource that you'll have. And everything on here, of course, does come up on the leaving cert. So touch wood on that. Right, so listen, I'm going to leave you at that. Okay.